Okay, good morning to all of you. Last few classes we are discussing about operator method to find particular integral. Okay, in last class we have been discussed the rule number 3. When source function will be sin x, then what will be the particular integral? In detail we have been discussed, and the corresponding numericals also we have been done. And also this proof we have been discussed that if 1 by d minus a into x will be equal to e to the power x integration of x, this is the source function. Okay, x e to the power minus ax dx, which will be very much essential for uh, numericals. In today class we are going to discuss the rule number 4 and its corresponding numericals. Rule number 4 and 5 also. So this is the rule number 4, that if source function x will be equal to e to the power ax into fx, then what will be the particular integral, that we are going to be discussed in this class, and corresponding numericals. And rule number 5, if x is a other function of x, that means if the source function will be any other function of x except uh, sin x, cos x, e to the power x, e to the power x, fx, except these functions, if other functions we are going to be consider like x, see, and polynomial also. Polynomial, suppose x to the power n, except these functions, if we have another function but belongs to x, that means suppose x, if will be sec x, that is a function of x except these functions. So if it is so, then what is the rule that we have to apply to find out yp, that also we are going to discuss, and corresponding numericals also we are going to discuss. So let's start from rule number 4. Okay, so if x equal to e to the power x into function of x, then the yp or particular integral will be 1 by f of d into e to the power x. That means 1 by f of d, this is general. In general we have to write 1 by f of d, that means 1 by f of d is going to be operated on this function, that is your e to the power x into fx. Here e to the power x is multiplied with another function which is function of x. So what will be the yp? The yp will be, here you can see e to the power x, it will be shifted to the f of d as f of d plus a. So here e to the power x is there, whatever the a will be there, it will be added with d. So and e to the power x will be come outside. So this will be e to the power x into 1 by f of d plus a f of x. So this is also known as a shifting property or shifting theorem. Okay, now we have to prove this theorem or property. First we have to consider d of e to the power x into fx, that means first derivative of this one. We have to consider the product formula. By product formula, this will be the e to the power x d of fx plus d of e to the power x, that means a into e to the power x, that means first derivative of e to the power x will be how much, a into e to the power x and fx. E to the power x, e to the power x taken outside, and fx also common. E to the power x and fx if I take outside, then we are going to get e to the power x into d plus a into fx. Now we are going to consider d square, double derivative of this one, e to the power x fx. Already first derivative we found the value is this one, and second derivative means d of this one, d of this value, d of e to the power x d plus a into fx. This is capital F. Okay, this is capital F. Now here also we are going to be consider the product formula, that is your e to the power x, as usual it will there, and d of d plus a, that means d square, c, d of d plus a, so it will be how much, d square plus dA. Okay, or ad we can write, fx plus derivative of this one, a e to the x d plus a fx. Okay, so here you can see e to the power x and fx are the common terms for this and this. Can be taken outside e to the power x fx. We got d square ad, here ad, here you can see here a into d, another ad will be there, a into a square. So ad is here ad is here. So 2ad into here a into a will be a square into fx. Okay, now this is nothing but is your d plus a whole square. So e to the power ax, this is nothing but d plus a whole square fx. Okay, now similarly dn e to the power x fx, that means nth derivative of this, we can get how much? See, first derivative e to the power x d plus a to the power 1 fx. Second derivative of this one is e to the power x d plus a to the power 2 fx. So obviously nth derivative of this one will be e to the power x d plus a to the power n into fx, right? So therefore f of d e to the power x into fx will be equal to e to the power x f of d plus a into capital fx. Here d to the power n is considered as fd, small f of d. D plus a to the power n is considered as f of d plus a. As you have been remembered, whenever we start to discuss about operator method to find particular integral, here f of d is considered as this one, nth derivative plus n minus 1th derivative of like this. That means this is represents the number of derivatives or function of derivative. Okay, so as this is nothing but your d to the power n is nothing but your nth derivative, so it can be represented in general form f of d. Likewise d plus a to the power n can be written as f of d plus a, right, into fx. Now we have to operate f of 1 by f of d both side of this equation, then 1 by f of d into fd, okay, into this much e to the power ax fx equal to 1 by f of d into this much e to the power x f of d plus a into fx, right? So here f of d got cancelled. We got e to the power x into fx. Here 1 by f of d, 1 by f of d, and as such this term has been written here. Okay, now we have to put f of d plus a into fx, this much. These two terms combinedly are considered as capital Y. That implies f of x will be equal to 1 by f of d plus a into y. This term is going to be divided into RS side, this side. Okay, hence e to the power ax into 1 by f of d plus a into y will be equal to, that means here instead of fx we have to put 1 by f of d plus a into y. So here e to the power x, e to the power x, instead of fx, capital Fx, we can substitute this one, 1 by f of d plus a into y will be equal to 1 by f of d, 1 by f of d into e to the power ax into y, right? So here you can see that 1 by f of d e to the power ax into y. See, 1 by f of d e to the power x into y, how much we got? E to the power x, e to the power x taken outside, but it is shifted f of d to f of d plus a. See, 1 by f of d e to the power x into y is equal to what we found, e to the power x into 1 by f of d plus a into y. Okay, so here y is nothing but is the function of x. See, this is the belongs to derivative, leave it, but y is the function of x. Likewise, if it is so, then instead of y, if I am going to consider another function, that is your e to the power ax into fx, 1 by f of d e to the power ax into fx, then what it will be? It will be e to the power ax move outside, and this f of d will be d plus a and fx into fx. Okay, again I am going to explain. See, 1 by f of d e to the power ax into y, how much we found? E to the power x into 1 by f of d plus a into y. Likewise, if we are going to consider 1 by f of d, 1 by f of d, e to the power x, f of x will be equal to, this a is going to be added with this one, and e to the power x will be taken to the initial. So e to the power x into 1 by f of d plus a into fx. Okay, here I am going to give a simple example. Suppose we have 1 by f of d into e to the power 3x into, suppose, sine 2x. Then what is the initial step? It will be e to the power 3x 1 by f of d plus 3. Okay, okay, f of d plus 3 into sine 2x. That means, suppose f of d is nothing but your, suppose d square plus 2d plus 3, like this it is there. So what it will be? So 1 by d square plus 2d plus 3 into e to the power 3x into sine 2x. If it will be like this, then the first step will be by this rule 4. What it will be? What we have to do? E to the 3x will be shifted to initial. 1 by wherever d is there, that will be shifting towards d plus 3. So it will be added with 3, because e to the power 3x is there. So d plus 3 whole square, 2 into d plus 3 plus 3. Okay, then sine 2x, like this, right? So this is the proof of this one. Okay, so this is also called as a shifting property or shifting theorem. Maybe this theorem will be asked in your exam, that you have to prove, right? So here I am going to suggest one thing, that here I directly done that derivative d of this one I done, and I found this one. Maybe you are going to be confused. Only for that, again here I have been done that derivative. That means d of this much, derivative of e to the power x, d of fx plus a e to the power ax into fx. Here I done, and also I got the same answer. Here d of e to the power x, d fx plus a e to the power ax fx. So you do it, no problem. So here d of, here we are going to consider the product formula. So e to the power x d square fx plus a e to the power x dfx. Again here also we are going to consider the product formula, a e to the power x d of fx plus, here e to the power x will be derivative with derivative means it will be a e to the power x or a square e to the power x fx. So just simplify it. Also you are going to get same answer, that will be e to the power ax. This is nothing but what? D plus a whole square into fx. So don't to be confused. Okay. So here this is the proof of this theorem or property. That property, using that property, this property, we are going to solve the numericals. So this is the numerical which is based upon this rule 4. Okay. So let's solve it. The question is that solve d square minus 1 y 6x e to the x by operator method. So first of all, we are going to find out the complementary function. In general, the solution of this differential equation is nothing but complementary function plus particular integral. The auxiliary equation is nothing but m square minus 1 equal to 0. So m equal to plus 1 and minus 1, two roots, two distinct roots. So complementary function will be constant c into e to the x, that is e to the ax. A means 1, e to the x, and d into e to the another b x, that is minus x. So this is your complementary function. Now we are going to go for the particular integral by using rule 4. Okay, by rule 4. So given that d square minus 1 y equal to 6x e to the power x, this is our source function. So this is in the form of what? E to the power x into fx. E to the power x is there, and another one function is multiplied with this one. So this is in the form of this one, means we have to apply the rule 4. So yp in general, we know that 1 by f of d, the source function, that f of d is nothing but d square minus 1. So 1 by d square minus 1, 6x e to the power x. So 6 is a constant, not to be operate anywhere, and any operator is not going to be affect this one. So it will be taken outside. 6 into 1 by d square minus 1 x e to the power x. So here this is nothing but in the form of what? E to the power x into fx. So now we are going to be use this one. We are going to use the shifting theorem that e to the power x will be taken outside. Here see, e to the power x means e to the power 1 into x is there. So here a is nothing but 1, right? So e to the power x taken outside 1 by here d plus a, that means d plus 1 square, square is there, minus 1 into x. So also here I written clearly that as 1 by f of d e to the power x fx is there, is in this format. So this is nothing but e to the power x 1 by f of d plus a into fx. In this case a is nothing but 1. So 6 into e to the power x 1 by d plus 1 whole square minus 1 into x. So 6 e to the power x d plus 1 whole square is d square plus 2d plus 1 minus 1 into x. 6 into e to the power x 1 by d square plus 2d. 1 got cancelled, plus minus. So d square minus 2d into x. So here e to the power x work has been over. So now here it is like this, 1 by d square plus 2d into a polynomial. So if we have a polynomial, then we have to use the rule that is your 1 by 1 plus x or 1 by 1 minus x into a polynomial. Already we have been discussed in our rule 2. Okay, so here we are going to do that 2d is taken outside. If I am going to take 2d outside, then it will 1 plus d square by 2d into x. So 6 into e to the x into 1 by 2d. Here d got cancelled, so 1 plus d by 2 into x. Now here 6 e to the x, 6 e to the x 1 by 2d, 1 by 2d. So this is in the form of what? 1 by 1 plus x. Okay, this is 1 by 1 plus x. So here x is how much? Here x is d by 2. So 1 by 1 plus x is nothing but 1 minus x plus x square by 2. Sorry, plus x square minus x cube, like this. So this expansion we are going to be used. That means Taylor series about origin, or you can say the so-called binomial expansion. So here 1 by 1 plus d by 2 will be written in the form of this one, like this, 1 minus, instead of x what we have to write? D by 2, then x square, that means d square by 4 and so on into x. We are not going to take the higher order because as it is x means double derivative will be 0. So we have to consider up to this much, right? So 6 into e to the x 1 by 2d, just multiply x with each term, x minus d by 2 into x plus d square by 4 into x, right? So here 2 6 cancel, 3 e to the x 1 by d, that this is your x minus derivative of x. Okay, derivative of x will be 1. This is nothing but d is nothing but d by dx of x is 1, so 1 by 2, and this is the double derivative of x will be 0. Now 3 into e to the x 1 by d is going to be operated on x 1 by 2 and 0. 1 by t 1 by d operated on x minus 1 by d operated. This is operator, okay, because this is nothing but a integration. See, already d is the operator, is represents d by dx. 1 by d is the operator. This is nothing but like this first integration. So 1 by d is operated on x, 1 by d operated on 1 by 2 on a constant, right? So this will be 3 into e to the x. This is the first integration of x. This will be x square by 2, and here 1 by 2 taken outside, integration of only one constant, that means x, so x by 2. See, 1 by d into 2, that means 1 by 2 taken outside, integration of 1, that means x by 2, so x by 2. So here we found 3 e to the x, x square minus 1 by 2, that is your yp. Yc already we have been evaluated this one, so y equal to yc plus yp. Yc value is this one, yp value is this one. So this is the general solution of this non-homogeneous differential equation. Okay, next we have to move to another numerical, is this one. Okay, so here question is solve d square y by dx square minus 2 dy by dx plus y equal to x e to the power ex into sin x by operator method. Okay, so as right hand side is a function of x, so it is a non-homogeneous linear differential equation. Okay, so how we are going to solve it? We have to find out the complementary function and particular integral. So the given differential equation, this one can be written in this format, that is your d square minus 2d plus 1 y equal to e to the x into x sin x. Here you can see the right hand side is in the form of e to the power x into fx. Here e to the power ax, here e to the power ax means a is what? 1, sin x. Sin x is another function which is the function of x, can be written f of x. So this is nothing but d square minus 2d plus 1 can be written as d minus 1 whole square y e to the power x into sin x. So general solution of this one, as we know that complementary function plus particular integral. So to find the complementary function, first we have to solve the auxiliary equation. The auxiliary equation is nothing but m square minus 2m plus 1. Sorry, this is plus 1. Plus 1 equal to 0. That means m minus 1 whole square equal to 0. That is m equal to 1 and 1. Two identical roots we found. So for this case, yc will be c one constant plus d another constant into x whole into e to the power ax. Here a is 1 means e to the power x. Okay. Now we have to find out the particular integral. In general, the particular integral is nothing but 1 by f of d operated on the right hand side of the function, that means x. Here x is how much? X e to the power x into sin x. We have to substitute this one. So f of d is nothing but how much? D minus 1 whole square. So d minus 1 whole square in is operated. Actually it is not into, this much operated on e to the power x into x into sin x. Okay, so here you can see that this is in the form of what? E to the power x into fx. So by using shifting theorem, here you write shifting property or shift, shifting property or shifting theorem. Okay, shifting property, what we have been discussed, the e to the power x will be taken to the initial and the coefficient of x. Here e to the power x means coefficient of x is 1. So this factor, this coefficient is going to be added with d. Suppose here suppose here we have e to the power 3x, that means it will be added as d plus 3. Suppose e to the power 5x will be there, so it will be added with d as 5. Okay, so here as it is 1, so here d will be d plus 1, minus 1 is already there, minus 1 whole square x sin x, and e to the power x moved to initial here. So this is the action of the shifting property. Okay, this is the action of the shifting property, that e to the power x will be moved to initial, and the coefficient of x here will be added with d. This is d plus 1 minus 1 whole square x sin x, right? Here 1 plus 1 minus 1 got cancel, and we found e to the power x into 1 by d square into sine into x sin x. Actually see, here 1 by d square is operated on x sin x. Like this language you have to remember, but oftenly I am speaking out, it is into this one. It is not actually into, it is operated. 1 by d square is operated on x sin x. So 1 by d square is nothing but your, see, if 1 by d is only single integration, so obviously 1 by d square is nothing but double integration. That means here 1 by d square operated on x sin x means 2 times integration we are going to be consider. So in this way we can write that e to the power x into 1 by d into 1 by d into x sin x. So 1 by d first operated on x sin x, that means first integration x sin x dx. So 1 by d is there, e to the power x also is there, e to the power x into 1 by d into integration of x sin x. First, consider islet, inverse, logarithmic, arithmetic, trigonometry. So here this is the trigonometric. So x, so obviously the first function taken outside, integration of sine x dx, and then minus derivative of this one is 1 integration of sine x minus cos x dx. Okay, and another integration. So this will be how much? Integration of sine x will be minus cos x, and here minus minus, and integration of cos x is your only sin x, so sin x. Then again 1 by d is going to be operated on this one, that means integration of minus x cos x, this is minus x cos x plus sin x dx, right? So separately we are going to consider the integration of minus x cos x dx, integration of sin x dx, right? So here minus taken outside, x is the first function, x integration of cos x, and then according to by parts rule, derivative of the first function, integration of the second, and another integration. So derivative of x is 1, integration of cos x is or sin x, another integration dx, and sin x integration is nothing but minus cos x. Okay, so here minus x cos x integration is your sin x, and sin x integration is your minus cos x, so minus minus plus cos x. Here is another minus is there, so minus cos x. So e to the power x minus x sin x, and here you can see that minus 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 plus minus cos x, another minus, so minus 2 cos x. So this is your yp, this is your yp. Already we found yc, so general solution will be yc into yp. Okay, now we are going to move for the rule number 5. Rule number 5, this is your last rule for the operator method. See, for according to this rule, if the source function x for a non-homogeneous linear differential equation is other function of x, other function means except, see, in the rule 1 we have been discussed a to the power x, in rule 2 we have been discussed about polynomial. Okay, polynomial means regarding x to the power n, like that. And again rule 3 we have been discussed about sin x and cos x, and rule 4 we have been discussed about e to the power x fx, and in rule 5, in this, according to this rule, except this, except e to the power x, except sin x, cos x, or any polynomial, if we have another function like x equal to, suppose sec x is there, then how we are going to be solve it? Okay, so according to this rule, yp in general, actually in general, particular integral is 1 by f of d is operated on this x. Okay, actually I am going to suggest one thing, that here it is 1 by f of d into x. Like that you are not going to be read, you have to read that 1 by f of d is operated on x. Okay, so here yp in general, we know that particular integral is nothing but 1 by f of d operated on x, that is your source function. But if f of d in the form of d minus m1, d minus m2 up to d minus mn, so by using partial fraction, that means here you can see that suppose 1 by uh, 1 by m minus 1 and m plus 1 is there. So according to partial fraction, by using partial fraction, this can be written as uh, 1 by m minus 1 plus 1 by m plus 1. Okay, 1 by m minus 1 into 1 plus 1 by m plus 1 into, here you can see, if I will add it, then in the numerator we can get m minus m plus 1 plus m minus 1. So 1 got cancelled, 2m. So for that we have to divide 2m. So here a is your 1, b is your also 1, like this. Okay, so as it is d minus m1, d minus m2 up to d minus mn terms are there, so 1 by f of d operator can be written by using partial fraction as a1 by d minus m1 plus a2 by d minus m2 up to an by d minus mn. So yp, now this is going to be operate on x, means this one is going to be operate on x. So yp will be, this one is operated on x. So individually it will be operate. So a1 by d minus m1 operated on x, a2 by d minus m2 operated on x, and so on, an into 1 by d minus mn operated on x. So in our previous class, we have been already proved this theorem that if 1 by d minus a into x is there, then this can be written as e to the power ax integration of x e to the power minus ax into dx. So here you can see this is a1 is constant, and here 1 by d minus m1 into x is there. So what we can write here, d minus a is there, means we have to write e to the power ax. So here e to the power d minus m1 is there, so we can write e to the power m1x integration of x, this x into e to the power minus m1x into dx. Likewise for this one, a2 is the constant, and 1 by d minus m2 into x, 1 by d minus m2 operated on x can be written as e to the power m2x integration of x into e to the power m2x dx. Likewise, if we are going to consider this one, that means 1 by d minus mn operated on x can be written as e to the power mnx integration of x e to the power minus mnx dx. Okay, because we know that this one, these things already we have been proved in our last class. So by using this rule, we are going to go for a numerical. This is the question that d square y by dx square plus y equal to sec x. We have to solve it by operator method. So this is a non-homogeneous linear differential equation, can be written as d square plus 1y equal to sec x, and the solution is nothing but complementary function plus particular integral, and corresponding auxiliary equation is nothing but m square plus 1 equal to 0, and the two roots are plus or minus I. So if the two imaginary roots we found, then the complementary function will be in the form of what, e to the power alpha x into c cos beta x plus d sine beta x, that we know. So here alpha, that means this is nothing but what, 0 plus or minus 1 into I. So here alpha is 0, so that this term will be 1 into c, and beta is your 1. So c cos x plus d sine beta is 1 x sine x. So complementary function we found c cos x plus d sine x. Now we are going to go for the yp. Particular integral, in general we know that the 1 by f of d is operated on the source function x. The source function is given that sec x in the question, right? So 1 by f of d is nothing but your d square plus 1, d square plus 1 sec x, right? So here sec x is the another function except e to the power x, sin x and polynomial. So for that what we have to do? We have to do that this denominator or the operator d square plus 1 is going to be written in this format, d plus 1 d plus I into d minus I. By using partial fraction method, what we have to do? We have to segregate this one as 1 by d minus I minus 1 by d plus I. If it is so, you just subtract it, it will be d plus I minus d plus I plus I. So d got cancelled, so in the numerator we can found 2I. So if I will divide 2I got cancelled, and we are going to get this much. So by using partial fraction, this much can be written as like this into sec x. So 1 by 2I is here. So here 1 by d minus I is to be operated on sec x, minus 1 by d plus I is going to be operated on sec x. Now first we have to consider this one, 1 by d minus I sec x. So here this is in the form of what? This is in the form of like this, 1 by d minus a source function. So here this is nothing but e to the power x integration of x e to the power minus ax. So here a is what? A is I. So it will be written as e to the power ix integration of sec x into e to the power minus ix dx. So keep e to the power ix as usual. So e to the power minus ix can be written as cos x minus I sin x by cos x into dx. Right? Divide cos x with each term. It will be 1 minus I sin x by cos x. E to the power x is there. E to the power x integration of this one 1 means x, here this one sin x by cos x, that means derivative of cos x is here but minus. So sin x by cos x, that means tan x integration we know that minus ln cos x. So already minus is there, so plus I ln cos x. Right? Now we are going to consider 1 by d plus I sec x. So here 1 by d plus I sec x can be written in the form of 1 by d minus I. Here minus I mistakenly I written, you have to just correct it. This is minus I, okay, minus of minus I means d plus I. So here d minus a, if I am going to follow this one, d minus a, here a is how much? A is your minus I sec x. So e to the power ax, as per this formula, e to the power ax, that means e to the power minus ix integration of source function is your sec x into e to the power minus of ax. Already a is minus 1 minus I, so it will be plus ix dx. So here e to the power minus ix written as usual, and sec x is nothing but 1 by cos x, and e to the power ix can be written as x cos x plus I sin x into dx. Cos x is divided with this one and this one. We found 1 plus I sin x by cos x. dx and e to the power minus ix is there. So e to the power minus ix, and integration of 1 will be x, and integration of this one sin x by cos x, or the so called tan x, will be nothing but minus cos x minus ln cos x. So I is here minus ln cos x minus I ln cos x. Okay, so yp will be how much? 2 by 1 by 2i, 1 by 2i, this much value. How much we found? This one, e to the power ix into x plus I ln cos x, and minus here, minus this much value is this one, minus e to the power minus ix into x minus I ln cos x. Again we have to solve it as like this, that here you can see that if I will multiply e to the power ix with these two terms and e to the power minus ix, these two terms, we can found e to the power ix into x. Here e to the power minus ix into x. So if I will take common as x, then what we are going to found? X, if I will take common, then e to the power ix minus e to the power minus ix by 2i, because already 2i is there. Here you see e to the power ix into x minus e to the power minus ix into x. If I will take common x, if I will take common x, then e to the power ix minus e to the power minus ix divided by 2i, right? Same thing it has been written. Likewise here you can see e to the power ix I ln x minus e to the power ix, here is minus plus, so minus minus plus, plus e to the power minus ix I ln x. I can take common I ln x. So what we can found? We found e to the power ix plus e to the power minus ix by 2i. Same thing it has been written here. Okay, I ln x taken common, e to the power ix plus e to the power minus ix by 2. And we know that this one e to the power ix minus e to the power minus ix is nothing but 2i sin x. Okay, e to the power ix is what? Cos x plus I sin x, and e to the power minus ix is your minus cos x minus minus cos x minus I sin x. So here cos x got cancelled, this is minus minus plus, so 2i sin x by 2i, and e to the power ix plus e to the power minus ix will be nothing but 2 cos x by 2. So here 2 got cancelled, 2i got cancelled, yp is your x sin x plus cos ln cos x. So finally the solution will be complementary function plus particular integral. Complementary function, we found that c cos x plus d sin x, and here yp we found this one. So this is your solution of the given differential equation. Okay, so here we have been finished the 5 rules regarding operator method to solve non-homogeneous linear differential equation and corresponding numericals. So I suggest watch this video carefully, write down the note, and ready for the next class. Next class we are going to discuss some miscellaneous problems. Okay, almost all problems I have been covered, but some miscellaneous problem we are going to be solve in our next class. Okay, so thank you so much for watching this video. Thank you.